Hey there, everybody. Welcome. It's nice to see you here in this beautiful SkyTour live stream meet tonight. It's Sunday, March 26th. Can you believe it? It's almost April, guys. This is Betelgeuse we're looking at right now. The orange cast that you see in the sky is actually due to the sunset. Okay. Before we go further, I'd like to welcome Daryl Mason. Hello, Daryl. How you doing?
Hello, Mark. I'm good, thank you. You? Hello, everybody.
Well, I'm doing okay, I my voice is coming back slowly but surely, and so I quit calling me Shirley, so we'll see what happens. I see a bunch of people here. First thing I have to do is I have to congratulate Darlene. That's right, Darlene made a big win today. First place. Their cheer team made first place, baby. That is so cool. Well done, Darlene.
Hey, Darlene.
That's why we named galaxies after you. So that said, welcome. And ta-da, there I am. So, I didn't have my camera on. That's why I said that, Daryl. You can't see that part. Welcome, guys, and tonight we're going to be looking, as I promised, we're going to be looking at Messier 100, and we're going to see the dwarf planet Ceres passing in front of it. Ceres is literally almost 600 miles, like 580 miles in diameter, and it's literally out past the orbit of Mars in the asteroid belt. So it is really just an incredible distance, but we're going to see the very bright planet, dwarf planet. Used to be called an asteroid. It's the largest, quote-unquote, asteroid in our solar system, which probably contributed to it being labeled a dwarf planet now. So Ceres will be visible. This is, like I said, this is Betelgeuse, and I'm looking at Betelgeuse right now to get a fix on the focus. And we're going to run through a focus adjustment here. We have a few clouds out there, but these clouds look like they're supposed to be at least lessening. So we're going to just make sure they do. And if they do lessen, then that's good. That said, let me run our focus test here. This is an automated process, and even if there's clouds, we can still get stellar points, and that's okay. It says no stars, and it'll have a few. So I probably have to increase our gain a little bit and start it over again, which is fine. So let's start it over. As you can see, we have more stars now, and I will do that. Okay, so now we will scan inward and focus again. Also notice that I'm going to be trying to talk a little bit less, which I don't think, there's some people that will say, yay! But it's so hard not to with all the stuff that's out there. I'm adding a V8, by the way. You can't really see it, but it's a V8. Okay, so first things first, Michael Hedrick was the first one here. Cyclone next, C&D Boy, Daisy and Zoe Amethyst, James Graves, hello, how are you? Thank you for coming. Make sure you subscribe, because we have wonderful objects to view on ultra clear nights. We capture objects in seconds that would take literally minutes to many tens of minutes, even an hour to capture. We capture them in just seconds. So it's good to see you. Izabela's with us. Hello, Izabela. Elisha Vieras is with us. Remember, she's the one with the daughter, Darlene, who won the cheer competition. Fantastic. Congratulations. And of course, Daryl's with us, as I told you. And Sam S. is with us. And we've got a few other people that are joining us for the first time. I wanted to welcome everybody. Tim F. is with us. And as the time goes on, we'll see how many more people join us to watch Ceres pass in front of Messier 100. Okay, So we've got our focus. We're going to now shift into the best focus mode. So there we go. That's our curve. We want that curve, and that's the best focus at the bottom of the curve, and that's where we are now. So we are a superbly focused telescope. Look at how nice and pointy those stars are. We're seeing Betelgeuse through some light clouds right now, but we will, again, continue to monitor that situation. If we look at our AllSky camera, let's see. Okay, I'm going to have to increase the exposure on that. So how was your day, Daryl?
Restful.
That's good. Let's do a 4-second shot.
I was lazy today.
Were you?
Oh, yeah. It's been really windy here, and it's so bad it'll beat you up if you stay outside very long.
Oh. That's not
and
too
now
bad.
we maybe got snow coming in tonight, so springtime in the Rockies.
Yeah. Now I looked at the weather, and these clouds are going to move out. They're moving this way. If we do another acquisition, you'll see which way they're actually moving. They're actually moving to the east. See that? And like last night, they will go and give us our view.
Hopefully.
No, I think they will. But they're light clouds, so we actually will be able to hopefully peek through them to see what we need to see. And while we're waiting, I'm going to show you guys something. This is a little animation that our own Izabela did for us. And I'm going to dig it out here. This is it. Okay, and I'm going to share the screen so you can see it now. That's Ceres right there. Okay. And watch now. See, it goes from there to there. She has the date. You'll notice it actually moves a little bit more. So it starts there, and then you'll see two spots. There's 1, 2. See? That's Izabela Melamed who did that for us. And that's Measure 100, and it's going to be crossing that tonight, going right across here. And we should see that happen. And if it's light clouds, we should be able to poke through those clouds. But I want to thank Izabela for doing this for us. That was very nice. Thank you. Right, and we will be adding to that, actually, as we move forward here. And by adding to it, I mean we're going to be taking more pictures that can go into this animation. And then we'll have it. Hello, Rascally. So we're just waiting for the clouds to clear a little bit. Because Measure 100 is not quite visible yet. If we look at our planetarium program here and start to zoom out, okay, do a find on Measure 100 right here, you'll see that it's pretty low in the sky right now. Its elevation, which I'll show you by bringing these lines up, is about 20 degrees right now. And it has to be around 40 for us to see it. So that means it's going to be right about here. And that'll take us just a little while. But meanwhile, if anyone has questions, or if maybe we can look at some cool stuff. Hey, while we're looking at Betelgeuse, wouldn't that be cool if it blew up right now? Izabela says it was so cool to see a dwarf planet moving. Yeah, especially one out past Mars in the asteroid belt. You know, that was cool. So yeah. Hey, Corey Williams, how are you? Well, what's going on in space tonight, Corey, is, well, this is Betelgeuse right now. And we still have a little red sunset because our telescope's out in Arizona in the desert. So we're catching some of the red light clouds that are illuminated by the sunset. But tonight, the dwarf planet Ceres, which we used to call an asteroid, a knee asteroid, is going to pass in front of a galaxy. And we'll see it's, it's just, of course, a line of sight thing. Ceres is only just over 2 astronomical units or more away. I can't remember the exact distance at the moment. It's like maybe 2.5, I'm not sure.
How far from Earth?
Yeah, from Earth, from the sun. Isn't it like about 2 astronomical units? I haven't checked.
I can check. I didn't think it was that far. Give me just a minute. I'll find out.
Okay. It's in the asteroid belt, so the asteroid belt varies. But we'll get an answer to that. Michael Hedrick has a question. You sure?
Okay, I take that back. Average distance, 207 million miles from the sun.
Yeah.
2.8 from the sun, 2.8 AU from the sun. So take away 1 for us, and it's about 1.8 astronomical units.
Okay. And we are at conjunction right now with Ceres.
We're at opposition
Or
right now.
opposition, I'm sorry. And that means that we're on the same side of the sun as Ceres, no?
Yes.
So that means that we are going to be racing by Ceres as our planet moves around the sun, and Ceres is going to appear to be going the wrong direction in the sky. And that's precisely what it's doing. It's going from east to west.
Yeah. Okay. Up-to-date information. 1.602 AU.
Okay.
So, yeah, and right now, Ceres is in opposition. You could draw a straight line roughly between the Sun, Earth, and Ceres, and that's when 3 or more objects in space are in a straight line. That's called syzygy, S-Y-Z-Y-G-Y.
Your favorite word.
One of my favorite words.
Excellent.
My favorite G-rated word.
Yeah. Fantastico. Well, as I said, it looks like Betelgeuse is somewhat clear for the moment, but I see clouds. You can still see them passing over it. Let's try and do, just for Betelgeuse's sake, let's just do a 6-second shot of Betelgeuse. Oh, that was a Starlink satellite that just came zipping through there. 6-second shot. We'll live stack it. And yeah, it looks good, doesn't it? Except we have to put it into the proper perspective here and get rid of this guy. Okay, take that down. Alright, well, there's Betelgeuse now. Look at that, isn't that pretty? The clouds actually make the halos look kind of cool. You know, at some point, when Betelgeuse does go supernova, and we are expecting it to, it's going to look like this. This is kind of what it's going to look like. But that'll be actual star brightness. It won't be the brightness caused by the diffusion of the star's light into the clouds. Yeah, Bucky, they're wrong. They had it past M100 last night too, and it's not right. The Sky Live, he says, has Ceres looking, going past it. you know.
Yeah, I saw that.
Yeah, but that's because the Sky Live can't be relied on. We know that for a fact because we figured that out last night.
It was the Sky Live that said Ceres is 1.602 AU away. Elisha asks, can you explain supernova to Darlene?
Oh, sure.
How old is Darlene, Elisha?
She's 9.
Oh.
I know this because I got a picture of Darlene with my book that Elisha sent us, which was really nice.
Oh, nice.
Yeah, I met her mother at Alien Con. It was very nice. Hey, David Reddick, how are you? So, let's explain what a supernova is. Okay, stars burn gas. They burn a hot gas called hydrogen. Hydrogen is the most plentiful, common element in the whole universe, and the stars compress that hydrogen and turn it into helium in their cores. But when they run out, a lot of things happen that quickly cause the star to get unstable. And eventually the star explodes because it literally is fighting a battle, pushing out with its light that it's pushing out with the radiation. And it's also got such gravity, it's trying to collapse itself. But it pushes out and pushes in like a balloon. You blow it up and the air in the balloon holds the balloon up. But if you pop the balloon, all that air can rush out, correct? So if you think about it, when the star runs out of all of the energy that's holding it up, it'll collapse. And that collapse from all sides on that core of the star causes the star to blow outward and blow up. And that's a supernova. It's one of the biggest explosions in the universe. Okay? And that's for Darlene, who's 9 years old and listening in the chat. So if you have any other questions, Darlene, please ask. You know?
We've looked at a supernova or two in the past here.
Just last night we did. Just last night we, yes, a jellyfish. That's a supernova remnant.
Oh, well, I mean a current supernova.
Oh, if that's right.
The one we saw last year in
Measure
Virgo,
66?
I think. It wasn't 66. It was
64.
64 maybe. It was in Virgo.
Mm-hmm.
And supernovas, Darlene, are so bright. There's billions of stars in a galaxy. And when that supernova blows up, that explosion is as bright as every other star in the galaxy is.
Yeah. And what they leave behind is this tangled web of glowing gas, which is so pretty. We've seen some of these, and they're really, really pretty. Hello, Cindy Murphy. David Reddick says, one of these days it'll be exploding and I'll miss it because of all those clickbait channels. No, you won't. You know why? We're not clickbait. And if it happens on my watch, you're going to see it. And you'll see it live in real time. This is live in real time, by the way.
I know exactly what channel he's talking about.
Oh, I bet.
YouTube throws it at me, too. Run outside. You know, Betelgeuse is exploding right now.
Yeah, those. Very funny, guys. Very funny. But I can tell you this. There's no astronomers on that channel. I am an astronomer. That's what I went to school for. That's why I'm doing all this.
Elisha and Darlene, I hope I'm saying your name right, Elisha. She's now curious how long a star can stay stable before exploding.
It depends on the star.
I'm sorry?
Depends on the star.
Well, yeah. Big, bright stars, very heavy, massive stars, they're called supergiants. They're the ones that are more likely to blow up in a supernova. And because they're so big and they burn their fuel at such a furious rate, they tend to live relatively short lives. You're talking like on the order of millions of years for really big stars,
Mm-hmm.
while smaller stars like our sun, they live for billions of years, thousands of times longer than the big stars do.
That's right. Give you an example. You know the belt of Orion, the three stars in the belt of Orion? 4 million years ago, when our earliest ancestor called Lucy was around and looking up in the sky, the belt of Orion wasn't complete. There weren't three stars there. Okay, because one of those stars is only just under 4 million years old, and Lucy is older than 4 million years. So we would have seen it. She would not have seen three stars in the belt of Orion. The other thing she would have noticed back then is that Betelgeuse wasn't orange, like this. Betelgeuse was actually a hot blue star. It was an O-type star, a star that's the hottest and bluest of any star in the universe. Those are the hottest stars. And Betelgeuse was one of those stars. But after it ran out of its hydrogen, as I was telling Darlene before, on its way to becoming a supernova, it expands into a gigantic red supergiant, which is kind of interesting because this sort of looks like the big red supergiant, doesn't it? It looks like we're looking at an ultra close-up of Betelgeuse, but it really is pretty. I'm really liking this. That's a beautiful image. I'm going to save this.
Okay.
Okay, there it is. And now I'm going to save it. Okay. So this will be the first image to go up to our server. Our server is located at SkyTourLive.org. If you go there and scroll down to the dark gray next section, that can take you to the online directory where you can actually drill down and get this very image just a few seconds from now, because it's already on its way up. Okay, so it's really, really cool. I hope you enjoy. I hope you enjoy coming here. And like I said, if you aren't familiar with us, it's a lot of fun coming here. A lot of people join us each night from all over the world, right? And this section over here, okay, that I'm outlining in red right there, that's our telescope control. This right here, this is our telescope computer, which will go off once in a while because it's just a energy saver. This is the telescope in the building, which is 2,500 miles away from me down here. I'm actually in Connecticut running this telescope out in Arizona. This is our stacking screen. This is where we actually collect all the images and put them on top of each other to reduce all the noise and make beautiful images like this. This, of course, is our main display. This is our telescope, our camera control system right here. And our focusing control system right here. And then everything else is some utilities and stuff. But that's the rough layout. And so I think that this is something that you can all enjoy. And hello, Marianne. Marianne is with us now. Marianne Robb is one of the three people in SkyTour LiveStream, the nonprofit organization. And I think that she deserves a shout out, because without her, this would not be here. Without Tara Diulis, this would not be here. Without me, I guess it wouldn't be here. But you know, it's cool. So there we go. Let's just back out a little bit here. Yeah, that's cool. All right, well, now that we've done this and we got Betelgeuse, I'm going to get out of it and go into a mode that I usually use when we're going to look for other things, and that's called a night vision mode. Right? And night vision mode, it is a mode that just on the screen when we don't have orange colors because of the sunset, we would end up having a green screen right now. And that's okay. We're going to increase our gain a little bit more. Go to 250. And what's the gain? Well, let me explain that too, because that's kind of important. The two most important things here are this, the exposure, and this, the gain. Okay? You'll see me playing with those all the time. The gain is how sensitive the sensor on the dedicated astronomy camera is, and the exposure is, of course, how long we're gonna collect light on that sensor. Okay. So those are the two things that are most important. You'll see me changing those most often. All right, so let me bring back our computer just by tweaking it a little bit. We can still see clouds passing across Betelgeuse. The other part of this is, the other part of our SkyTour live stream is the live planetarium. This live planetarium allows us to literally move the telescope wherever we want to by just doing it like this. Now, I'm going to select this object here. Okay, this is called the Beehive Cluster. It's a cluster of stars. And we're going to go check it out. And I'm going to tell the telescope now to go. So I just told the telescope, go there. And you'll watch it move over my head. There it goes. And on the screen, you see it doing it. And I'm going to wait for the beehive to come in. Look at that. This is actually quite nice. So that's without the night vision mode, and this is night vision mode. Very nice. So we'll center it up. In order to get a telescope to do what I'm doing, it takes time. It takes some attention to making sure that the telescope is aligned. And we have to make sure that the telescope is pointing north at the north pole, not the North Star, but the North Pole. The North Star is close, but off a little bit, off enough so that it wouldn't actually. It's off enough so that we wouldn't actually get a good read on things. Things wouldn't show up in the field. Okay. So this is the Beehive Cluster. This is a live view. It's a 1 second exposure. And this, like I said, the reddish cast is due to the sunset colors in the sky. Those will change as time moves on. It's already getting a little bit fainter. But let's actually go in and first things first, I'm going to call this what it is. It's Measure 44, open cluster. All right. And I'm going to do a 12-second exposure. Let's see what this does on this right now. Now, the exposures, even though there's some light clouds going over this, those exposures will actually they will actually make it so that the clouds get sort of fuzzed out. Now that's not good either. We want no clouds, and as we're waiting for them to hopefully clear, we can actually do this. So now I'm going to do the stack. You'll see the first 12-second shot. That's Betelgeuse again. We already captured it. And there is the beehive. And you can see that the beehive has a color cast to it, which is changing as we had said. And we're going to apply the sky to it. Let's start again. All right. Izabela, thank you for putting that up there. Izabela put the link to Betelgeuse. Okay. Now, whenever we have a moon out, we will find that our colors might just get a little bit strange, and we still have some reds, and the evening colors, they might even look purple at a time, because once the sun sets, we get that deep red on the horizon. The camera is so sensitive that even though it's not pointing at it, it's gonna still pick it up. So that's why we actually continue to take photographs. And we actually then managed to get rid of a lot of this noise. All right, so it's looking good. And that's the Beehive. That's Presepi, known as Measure 44. Michael, come back when you get time. Just go to your ship's replicator and say tea, Earl Grey.
Make it so.
Hot. Yep. Edward Parkhurst, nice to see you.
Edward, a couple of people answered your question. I did. You asked what we're looking at or what's going on. We're looking at the M44 Beehive Cluster. Messier 44.
Yeah, and part of the problem, Edward, is I neglected to do something very important. And I'm going to do it right now. I normally do this, and I guess waiting for the clouds to clear, I didn't bother, but let me just throw this out there right now. This is the Beehive Cluster. It's an open cluster of stars. It's beautiful, and we are waiting for clouds to clear. We have a few. I'll show you where they are. Okay, this is the last shot we took, and we're kind of peeking through the clouds. This is bird poop on our dome camera. So, okay, well, you see that? It's starting to clear a little better. We're starting to get some clarity here. This is good. Edward is in North Carolina. Excellent. Thank you so much for joining us tonight. And make sure you subscribe and hang out with us. I mean, this is live astronomy, and we don't do wide field stuff with like with just a camera lens. We're actually working on getting deep sky objects, and some of the things we have imaged are so utterly phenomenal that it's literally hard to put it into words how beautiful it can look. It really is. Okay.
Edward, the cluster is in the constellation Cancer, the Crab. Its Cancer is between Leo, the Lion, and Gemini, the Twins.
Here, I'll show them.
Okay.
So let me get rid of my elevation. Okay. Here is Cancer the Crab right here. Okay. Here's the Gemini Twins up here. Okay. And we have Ceres, the unicorn, here. And just a little bit relative to where Orion is. Okay. Let me show you. Okay. These are the stars of Orion here. There's the Belt of Three. And Betelgeuse, Bellatrix, Alnatak, Alalam, and Mintaka. And then we have Saif. And then we have Rigel. And then to the upper left up here, that's where Cancer the Crab is. Up there. Okay. Literally, if you just go from the middle star in the belt and go kind of on a diagonal under Betelgeuse, you'll kind of get to it. And the Gemini Twins are up there too, Castor and Pollux. Alright, so that's where we are in the sky right now. And I'll zoom out a little more. And you can see the winter Milky Way here, okay, in our planetarium program. It doesn't show well on a night like tonight in reality because the moon is just bright enough to kind of dull it and make it not look too good. But I would like to capture some cool things for you to see before we move to our main event. All right, and so we'll do that too. Let me just do one more shot here and see if we have some clarity. Okay. So it's going to be breaking up, let's hope, and we'll get our skies back shortly. This happens once in a while, but we do have 300 clear nights a year, so that's something that is important.
Sure you do.
Oh, let me take that out of there.
Chamber of Commerce here likes to brag that we have 300 sunny days a year in Colorado. What
That's
they don't
during
tell
the
you,
day.
that's usually during the morning here.
Edward Parker say, I must say that the channel of yours is quite impressive. Well, thank you, Edward. You know, we've worked really hard. You know, this telescope you see up here is SkyTour West 1. We're going to have a SkyTour West 2, right? And we have a SkyTour East. And that telescope is sitting behind me because we're putting it into a new building in hopefully the next couple of months. And it's going to be sort of like a mobile type building. In other words, modular. We can move it wherever we want. But it'll be kind of like a temporary building out here in the east. So we could take it to different places in the east, which would be very beneficial. All right. So there we go. I'll save this even though the moon's out and even though we have clouds. Okay, so that'll end up there. And we'll go back to our night vision mode that I was telling you about. And we'll get rid of our stack. We don't need it anymore. And let's do the night vision mode. See, the colors are a little more different now. They're a little more muted. And the clouds are actually, they have some red sunset light in them, which is why we're actually seeing them is this orange color. Okay, so while we're waiting,
Can I ask a favor real quick?
Yeah, go ahead.
Elisha was asking about a bright star in Virgo. Can you pull that over and show her Virgo right now?
Well, yeah, because you see Spica.
Virgo's too low for us, Elisha. Right now, it'll be higher later in the evening, but we can show you what I was talking about. There's Virgo just on the horizon right now.
Right down here.
And Spica is just about to rise above the horizon. It's the brightest star in Virgo. As I said, it represents an ear of wheat in her left hand. It's right there where that corner is. Its name is Spica, S-P-I-C-A.
Yeah.
She's holding it in her left hand. Right by her left hip. There you go.
So I couldn't actually see it at this point because it's below the horizon, and I removed the ground so we could do that. Okay, but that's Spica, and it's a very blue star. Hey, Sean, thank you. Sean says, someone told me long ago there's a calm before the storm. Yeah, that's right. Well, thank you, Sean. That's very kind. Thank you for the super chat. Yeah, and in case I didn't make it clear, yeah, Edward, I'm in Connecticut. I'm 2,500 miles from this telescope right here. But I did go out there a number of times, and with Marianne Robb, who's in the chat, and with Tara Diulis and other people there, and of course the landowner who graciously allowed us to squat on his land with this observatory, we were able to build it out there. And we have another one that we're doing out there as well. So we'll have a total of 3 buildings and 3 observatories that I'll be managing with our nonprofit. And I think that's pretty cool. So, right now, let's go from here. Let's go to something that everybody knows and loves and give it a shot just so people can see it. It actually came out really nice yesterday. We'll look at it again tonight before we look at Ceres. So here we go.
Cyclone wants to know, how did Jupiter get such fast rotation?
That's a question that requires an awful lot of backstory. But in short, when Jupiter was formed, it formed at the same time as the other planets. And its rotation is dependent on a number of things. It's dependent on how much other mass is going around it. All right. It depends on the amount of mass within it. And if a planet starts out as very large and then shrinks and gets smaller, then like an ice skater pulling in the arms, it'll start to spin faster. Stars do this too, by the way. And that's why when stars collapse and form neutron stars and white dwarfs, they can rotate quite rapidly. Supernovae are just the cores of the stars left over, and those are the neutron stars and pulsars in the core that form the star, that were formed by the collapse, I mean. And those can rotate at unbelievable speeds. So it's a matter of, it's called conservation of momentum, angular momentum. And so when the star is spinning, when it collapses, they will spin faster. You can see the clouds passing in front of it. This is the Orion Nebula, by the way.
Cyclone Jupiter is a gas giant planet, so the gas is compressing, and therefore the planet shrank. To say it's shrinking is sort of a misnomer.
Its gravity contracted it.
Its gravity is making the planet. Its gravity made the planet contract to a state of stability. Okay. And that's how big Jupiter is now, and that's why it spins so fast. Because like the skater pulling her arms in, centrifugal force, she pulls her arms in, makes it spin faster.
Okay. Thank you for that, Daryl.
Yeah.
Okay, so this is now the Orion Nebula. Let's see how this looks. Now we got clouds, but you can see this really pretty view, and I can actually kind of cut through the clouds right here. Kind of looks soft because of the high clouds, but that's kind of pretty looking, isn't it? That looks really pretty. That's nice. Ooh. Okay, that is nice. Edward Parker says, so the rings are leftover stuff that didn't get made into it, or what? Oh, like for example, Jupiter's ring or Saturn's rings. There's another physical law that Saturn and Jupiter and Uranus follow, and that is they have a certain distance away from them, that anything within that distance that's a solid body of a certain size will get torn to pieces, because the gravity on the front side from the main planet is pulling on it more than the gravity on the back side. So that's called a Roche lobe. The area, the Roche limit, in fact, is the area around the planet where a spherical body can still survive. Go inside that Roche limit by just a little bit, that's problematic, because then the differential gravity becomes too strong for this spherical body to hold together. Okay, and so that's why Saturn has rings, because there was a body in there that probably never formed a moon, but couldn't, because the gravitational forces just didn't really allow it to. So that's why we have Saturn with rings. Incidentally, Saturn's rings are in fact dissipating. In only another 1,000,000 years or so, Saturn will just be a yellow planet in our solar system. It will not have rings anymore, because the rings are actually falling and spiraling into the planet itself. We didn't know that, by the way. Well, I'm amazed we can still see this through here. Look at that. Let me clear this and see if we get another. Let's see what this one looks like. Yeah, see? It's clear here, and we have a little bit of a cloud there. That's neat. Now, just to get an idea how big our field of view is, we have a special telescope that we have here. This one, actually, the telescope that you see right there is the only one on Earth that is modified in the way that it's been modified to show this big a view. There's other telescopes that use this technique, but this is the only one of this particular brand, and especially the f8 telescopes. f8 is the photographic speed, basically, and this photographic speed is the only one on the planet that has this particular lens system installed to help it go 25 times faster in photographic speed. So this distance from here to here is just over 2 degrees, and this distance from here to here is just over 1.5 degrees. So it's 4 full moons across by 3 full moons tall. And that's what this telescope is good at, showing you massive tracts of space. And that's just what we're looking at right here. That's pretty cool. So, let's see if we can... Looks like we momentarily lost some clouds. I'll clear it again, see if we lost these clouds now too. Yeah, well, not sure. Let's go take a look. If it's clear enough, I can show you Orion. Hello, James Graves. How you doing? Marcin, how are you? Good to see you. Okay, here's Orion. You can barely see it. There's Betelgeuse right there. This is the belt. 1, 2, 3. Okay, there's Rigel. And we're looking right here. So we have a few little clouds. Let's do one more. Okay. All right, so we're going to wait it out. And again, for those waiting for the view of Ceres passing in front of M100, the galaxy, the beautiful grand design galaxy that is Messier 100, we have a little bit of time to wait for it to rise above this wall of our observatory right there.
Marcin, Galileo discovered the rings around Saturn, but his telescope was small and didn't really perform very well. He couldn't discern them as rings. What he saw, he called them ears. Ensai, if I remember right, was the word he used to describe them.
Ears.
Yep, he thought Saturn had ears.
Interesting. All right, let's do one thing here. I'm going to do this and zoom in on this. Okay, we have a little bit of focusing we can still do here. Let's see which way we want to go.
Mark, would you excuse me a moment, please?
Sure thing.
Be right back.
Yep. I'm going to just work on the focus here a little bit. You look in the center of the Orion Nebula here, you can see 1, 2, 3, 4 stars. This is called a trapezium, and these 4 hot young stars are what power the Orion Nebula. And they are really quite hot and young. Marcin asked a good question. Would we be able to see the surface roughness of Ceres with the light of the galaxy from behind? Not with this telescope. But one thing that I would like to see done, that we can't do with this telescope as well, is to see if the galaxy's light is bent by the gravity of Ceres. Because that's something that can and does happen. That's called a gravitational lens. So it'd be interesting to see if the light coming around Ceres is bent at all. I bet it is. I'm actually quite sure it will be. Alright, so I'll zoom out here a little. And let's go back to our maximize view and see. Yeah. Waiting for the clouds. So those of you that are new, thank you for coming out. Make sure that you do subscribe, because we actually do have a great time here. Just ask the people in the chat. They'll sell it over me, you know, and of course it's free. Look at that, we're getting clarity now. Yay. That's nice. So, looks like we're heading into the clear zone finally. Let's wait it out. There goes a satellite. You know, when you look at the Orion Nebula, one of the things that I don't want you to lose sight of is that you have these side, looks like these aprons of gas. This gas is really very fascinating because you're looking at oxygen, which makes them look green and blue here, and this is hydrogen. Okay, ionized oxygen looks green, ionized hydrogen looks red, and there's only a few colors that the universe provides to you. All right, and you're gonna see blue, you're gonna see white, you're gonna see yellow, you're gonna see orange, and you'll see red in the universe, or a mixture of colors depending on the nebula. For instance, if we go up higher here and look at this nebula up at the top, okay, which is kind of hard to see because it's in the cloud. Well, as a 1 second shot anyway. But I can just take another to show you. So the universe, again, only has a certain number of colors that it's going to put in front of you. And one of those colors that you don't see is green, which is kind of interesting. There's no green stars. There are no green stars. There's green nebulae. Okay, but what are they? Green nebulae are actually the ionized oxygen. So that's a color that the ionized oxygen makes. Okay, we're still waiting here. Yeah, it's hard to see it here. Looks like I'm looking through it with dirty glasses. Hey, Michael, welcome back. Okay. Color correction. As the clouds clear, we'll be able to see this much better. But what we're looking at here is we know about the red and we know about the greenish blue. This is regular blue. This is a reflection nebula. Right? So dust, this is all dust in here. And this area shows much more beautifully once we actually do it and image it without clouds. But then you see this side in here. This is magenta in here. That's actually not magenta. It's still red, but it's inside a blue nebula. So red light coming out of blue light makes a magenta light coming out from the inside. You got to go into into your head and start thinking about how colors work with light, and that's what we see. Okay. So you're in North Carolina. So you're actually, you're right. It's 11:30 for you. Edward says he wants to thank us for the replies. Of course. Make sure you subscribe, Edward, and click the bell and drop it down and say all notifications so you'll get the notifications when we come online. You know? Hey there, Marco. But thank you for coming. I'm glad you joined us for a little while. Now, that's the question. He writes, when will you be back on? Well, that's a question. That is dependent on the weather. But we try to stream on as many clear nights as possible. So I have a feeling that, I was speaking for A&E and History Network actually out in Los Angeles a couple weeks ago, and then I had to speak in Roswell after that because I worked for those guys, and I ended up getting sick, and I ended up with losing my voice, so that was really tough. So it's only coming back now, so as you can tell, it's kind of rough. Well, anyway, thank you. I'm glad you subscribed, Edward, and I'm glad you have been subscribed. Yeah. C&D Boy says, oh, okay, he's putting up a link. Thank you. Thank you for putting up our link. All right. Let's go. Let's go look and see what our sky looks like.
It does appear to be opening up.
Mm-hmm. We have some. See, we have that little streak in here, which is what we're looking at.
Yeah.
It's all right. Thank you, Elijah, for that helpful tip to Edward. Patricia Slama, how are you? Nice to see you. Thank you for coming out. This is our AllSky view right now, but we're currently imaging through some light clouds, the Orion Nebula. This is all live astronomy. Live. I'm going to clear this because I want to see if we can get another view here. That's looking a little good. That's nice. That's called the Running Man Nebula. This is called the Orion Nebula. There's a dark cloud of dust in here, and it's very obvious when we start to add more to it. So we'll see it. And whoa, there's a Starlink satellite. I'm actually pretty sure that's a Starlink satellite. We tend to get them, they come in at that angle, and then they go across too. So they're doing crisscrosses like this. And that's about the speed. They're able to zip right through. Well, Libra and Libra season, she says. I'm a Libra. My birthday's October 17th. Oh, yeah, the color's stunning. And Patricia says she likes the color. If I actually bring this down and we just remove this, you can see some of the details of the color in here. Look at the details in that clouds. Isn't that amazing? I mentioned before the green, the greenish blue here. This greenish color, this is the light of ionized oxygen. And this light here is the light of ionized hydrogen. Really, really pretty. October 2nd, okay. Oh, look at that. Mm-hmm. Really cool. Well, that's good. Well, Patricia, thank you for finding us. Make sure you subscribe. Okay, let's see. Let's see if we can pull out some of our dust. I'm trying to. I'm being rather unfair to my telescope because it's being crippled by the clouds a little bit, but you can see the dust very clearly there. If I pull back a little bit, now you can see. Pretty cool. As I tell people, this dust to me, this dust is all in front of what's in back here. Okay, this is in front of this nebula. So this dust is here, and we got the bright nebula, the bright hydrogen gas that's glowing behind it. All right, and this is all dust in here as well, but you can't see it because it's sufficiently diffuse and dark. We'd have to take much longer exposures, which we've done. And this entire region that you're seeing here, entire region, is totally covered in dark dust. So, but you can see that. See, in this dark dust, it's. And I've mentioned this before, and Daryl has said this before too. This dark dust is, to me, the seed of life, because it's composed of carbon atoms, which were carbon-based. It's composed of silicon atoms, and then there's a smattering of all the other elements in the periodic table that stars make. And all the stars in their cores, they fuse one element into another. And that, when those stars die, those elements get released back to the interstellar medium for the biggest stars. And in a slower process, get released back for the smaller stars like the sun. But still, it is actually a process that has seeded this interstellar medium with all of this gas and dust you see here. Previous supernovae and stars like the sun that have died, that have basically released all of their contents to the universe again. Hey, Science Bob, what's going on? That's Bob McGuire. How you doing, Bob? You notice how the Starlink satellites, they come in at an angle and then get more. It's actually, if I take a longer exposure, I'm just doing 10 seconds, but if I take a longer one, you'll see dashes in here and those will be the geosynchronous satellites. And Bob says, good shot. You know, it's a good shot. But we're actually looking at it through clouds, Bob. You know, but still we can see it. Light clouds, I should say. Very fine stars in here, Daryl.
Uh-huh. Lots of red ones.
Yeah. And there's that dust I was telling you about. And there's the magenta color of the hydrogen gas that's glowing, but being seen through a blue glowing nebula. Yeah. So let's go. I'll I save some of the good shots. This is kind of cool. All right, so we'll save it anyway. Even though it's not the best that we do. And let's go over and let's go see if we can find Measure 100 yet. I'll bet not. We probably can find it, but I don't know if it's going to be. We'll see. Let's go see if it's something we can image right now. Excuse me. Okay, so we save that.
I'm sorry, I was distracted. Where are we going now?
We're going to try and see if we can bring up Measure 100.
Oh, okay.
Hey, Lawrence Smith, how you doing? Lawrence Smith says he sees a man's face. Maybe he's looking at Bill Murray eating a baby Ruth.
Maybe. You said it, I didn't.
Well, you're the one that tells me that's what you see.
Yes, I know. I see a couple of different faces in there.
Yeah.
Right now, I can barely see Bill Murray. With longer exposures, I start to see Mr. Burns' face in there.
Do you see Bill Murray better here?
Barely.
Okay. All right. Well, that's cool. Again, pardon me, guys, because I have only just started to get my voice back. Hello, Starshine. Okay. Okay, let's see if we can get Ceres, the topic for tonight, in the view. Here we go. He wants a telescope move. Here it goes. Let's go 1 second. Night vision. Jeez. Okay, if you look up here, you see the telescope is actually pointing a little bit toward the building. So we're not able to see it yet, but we will. Take a few minutes, a little longer. Oh, Izabela, thank you for putting up the link to the Orion Nebula. That was very kind of you. Izabela does, besides doing the tables of contents of all of our videos, she does image processing as well with me on all the images that we take. And we produce these really, really beautiful images. So if you want to see some of those images, she has a link to her site, and you can also see them on SkyTourLive.org. Not hers, ours, the ones we mutually do. What's a question, Michael?
Michael, it depends on what you're talking about. If you wanted, they used to call galaxies spiral nebulas, and
Yeah.
if you wanted to call them nebulas now, they're over. Some of them are hundreds of thousands of light years across.
Yeah.
Run-of-the-mill nebulas aren't that big, and I've drawn a total brain lock here. How big is your Orion Nebula, Mark? I forget.
It's about, I'd
40,
say,
50 light years across?
well, the main part of the nebula is like 24.
Okay.
But overall, it's bigger. It is bigger. We're going to go to another object now. One that we love is going to swing the telescope around the other way. And let's see if we're in the clear.
When we look at planetary nebulas, they tend to be self-limiting in size, I think, just by how far the excitation by the ultraviolet released by the white dwarfs in the center
Mm-hmm.
can reach out. You're talking the order of just a few light years for them, I believe.
Yeah. They used to think it was like 2 light years, but we know that some of these nebulae can actually be larger than that.
Yeah.
So there's other processes going on. As that gas expands out and it's being ionized by the white dwarf's ultraviolet energy. Sorry about my voice. This is crazy. I'm sorry. As it's being ionized by the white dwarf, you also have that material colliding with the interstellar medium. And because it's moving out so fast, when it collides with the interstellar medium, it gets heated up tremendously, and that could also cause it to ionize. So that kind of expands the size of the nebula. And speaking of nebula, we've got one right here that we're looking at, which I'm going to go check out in here to see. It's going to be right about here. Oh, I think we're in the clear with this. Okay. All right, we're getting our clarity. Okay, this object here, this is called the Rosette Nebula. And we're waiting for Ceres to rise up high enough to be able to see. So the Rosette is a beautiful star cluster right here, and it formed in the middle of hydrogen gas and dark nebula, dark dust. And when the stars formed, they're very, very hot, and they push outward with their radiation pressure, and they literally are carving out a cavity around themselves. And that cavity is characterized by this dark hole you see here. Okay? So let's see what that dark hole actually looks like. Let's do a 25-second shot. We are guiding this right here. These numbers show that we're guiding. We have a guider scope that you can't see. It's on the other side. So,
Patricia wants to know if either of us are into ufology. That's a loaded question, Patricia.
well, Patricia, I'm the chief photo and video analyst for the largest UFO organization on the planet. So I am MUFON, Mutual UFO Network's chief photo and video analyst. So yeah, I guess you could say I'm into UFOs. Okay. All right, let's do our live stack now. And we're going to not do anything. We're going to just say clear this and check out the new image. I don't know if I've seen your pictures, Patricia. How would I see them? Look at that. Look at that. That is the Rosette Nebula. Stunning. Look at that, guys. This is beautiful. And the music is perfect for it. There's that cavity that I told you about. Carved out by those hot young stars. Tendrils of dark nebula lace this beautiful web throughout the nebula in 3 dimensions. So some are coming toward us, some are going away from us. It's just a very, very wonderful, beautiful region of space. I think Patricia is saying, you studied my case.
No comprende.
The network builder. I don't know what that means. Patricia, sorry.
Laugh and the world laughs with you, Cyclone. Cry and you cry alone.
Why is he not happy?
I have no idea.
What's the matter, Cyclone? Look at this. Beautiful, beautiful, beautiful.
Probably mad at me.
Why?
I told him not to put words in my mouth.
Wow. Another name for this object is an emission nebula because we're watching this emission of red light from the hydrogen gas. So let's actually just do this. Let's move this out of the way. Okay. And let's pop this down below and just enjoy the full screen appeal of the Rosette Nebula. Here it is. Put that out there for you. And we'll take the object ID out so you don't have to see this the whole time, and then we can zoom in more. Okay.
Michael, what did you see at Christmas?
Yeah, John, this we can enlarge these to wall size and make wallpaper out of them for people. We've had a doctor's office has asked if we could do giant wall pieces, and yeah, we could. Hello, Terry Haig. Terry Haig is here. Yuritsa Morales, how are you? I know. Es muy hermoso. Thank you, Ray, for putting in the Rosette diameter there. Look at that. Wow. Now, as beautiful as that looks, you also have to understand that the moon is out and we did have light clouds. So, you know. But Patricia, we'll look at your pictures later. We can't do it right now, obviously. And Izabela was just saying what she saw, and you know.
Excuse me.
What was that about?
Nothing.
Oh. Well, Bucky, aren't you Ray? I think you're Ray Tulipsky. Okay. No, Patricia, no one's harassing you. Just take it down a notch. Izabela is one of our favorite people here, so you might want to reevaluate that. Cyclone, there's a number of things we've not seen before that we wanted to have. I have a list right in front of me, but the nighttime sky isn't clear enough for us to see them. So, in other words, with the clouds that have been in the sky, it's been hard to actually steer the telescope toward those and actually see them with quality. But we'll do that. We have an event tonight, and that's the that Ceres is passing in front of Messier 101. Messier 100, I'm sorry.
There's lots of things that we have never seen before. They're too far away. We need a bigger telescope to see them, or they're below the southern horizon, and we will never see them. Michael or somebody mentioned the Tarantula Nebula.
Oh, I'd love to see that.
I'd love to see the Tarantula Nebula, but we cannot see it from here because it's in the southern sky.
Okay. Oh, it's Puerto Rico. Estão Puerto Ricano. Excelente. Well, welcome to SkyTour Livestream. Make sure you subscribe and hang out with us tonight. I've been in Puerto Rico. I love Puerto Rico. Actually, I have cousins in Puerto Rico, believe it or not, and I'm just amazed. I didn't know I had cousins in Puerto Rico. So that's very good. Okay. So if you notice, guys, you notice now that we can zoom in to this a lot more now because enough of the detail has come in and enough of the stack has occurred. We've got 23 images stacked here. And now what we'll do is I'm going to go and I'm going to add a little enhancement. If you watch all this detail, okay, watch what happens to it. Ready? Watch this now. Okay, watch. Look how much sharper this detail is. It's really, really pretty now.
I didn't see it change.
Well, thank you for that.
I didn't.
Okay.
I'm watching.
Okay. And then on. Let me... I think this probably will show you better.
I know. I've seen you toggle on other objects with the unsharp mask, and some I see a big difference, some I don't see a difference at all.
Interesting. Okay. You should be able to see this now. Okay. See that? Look how sharp that is. Look at that stalk right there.
Maybe a little.
Okay. Actually, John Proctor, what we want to do is we want to get a below the equator observatory at some point. One thing I'm good at is being able to access and use things remotely. Obviously. So this is something that I think is very important. Boy, can you imagine that, Daryl? Got a southern observatory? Oh my gosh. I'd have to learn all those constellations. I'd have to learn all the objects.
Yep.
I'd have to be ready to see Orion upside down. You know?
I still try to get my head around southern hemisphere, southern sky images I see sometimes.
Yeah.
I saw one earlier today. It was of the Milky Way, but it was taken from the southern hemisphere. And I could see the Pipe Nebula. I could see it pointing at Antares and Scorpius. But everything was upside down, I guess. And,
Yeah.
you know, I had to tell myself that, well, it still rises in the east and sets in the west. I was having a really hard time with it today.
I guess you could plan ahead and figure out how to make that work for you, because what you do is you just lay down on a blanket the opposite way.
Yeah.
You know? Oh, I know what you're talking about, Michael Hedrick. He says the top is a jumping spider with two red eyes right here. That's it. There's Michael Hedrick's jumping spider right here. See the two eyes?
I see a bat.
Well, I see Michael's jumping spider.
I see a bat.
Okay, you can see a bat. That's fine. Izabela, your dedication to the SkyTour LiveStream knows no bounds, and so I just want to publicly state how much we absolutely adore you. You are so helpful. You do such great work. You're such a good artist. All right. Okay. So now you can see this beautiful central area within the nebula.
Looks like Superman came out of the phone booth.
Huh? Where? Here?
Chat.
Oh. Oh. Hey, Ray, you're funny. Mild-mannered Clark Kent. Burning his barns. Beautiful. Okay, let's that's just a beautiful, beautiful nebula. And let's go back to our histogram, do some darkening up of the sky background just a bit. Okay. color correction. That's good. So look at that. Even with a nearly first quarter moon, our filters allow us to see a lot of really, really good detail. So that's nice. Otherwise, it would be really just very, very bright, you know. Now, if we look at this in negative, okay, this is a negative image showing what this might look like. Okay, again, this is all real time, so you see the stars as black dots, and you see the nebulae. And in astronomy, we'll often use inverted images like this to assist us in doing some analysis. But that's the real thing, I assure you. So we can zoom in like up here. Let's go back to Michael Hedrick's spider. Okay. So the two orange dots. Now if we invert those, you can see that they're now bluish dots because they were red. And so this is a way for us to more easily count the red stars. Because when you invert it, these faint blue dots show up where sometimes you might not see the red dots because they're a little bit faint or hidden. So that's cool. Yeah, I kind of been hiding that inverted thing here, you know, Anya. I've been hiding that from you guys. I haven't used it a lot, so I just wanted to let you know that. Okay, we have enough of these, so we've got Rosette Nebula defined up there. Okay, and once again, just so you know, they'll put that out there for you. That's the Rosette. Let's bring back our telescope here. Okay, and let's save it. So our Rosette gets saved. So this is heading up to our server. Save it exactly as seen. By the way, Lucy Clark, I owe you a hello. You've been here for quite a while, and I haven't said hi to you. All right, and I want to let people know that you publicize us like no tomorrow on Facebook, and I just wanted you to know that I notice. Thank you. Let's see if we can darken this up a bit. Oh, that's beautiful. Okay, so we'll save exactly as seen. Okay, and do one more save. Okay. Very nice. Nicey nice. Now that we're in the clear, I would like to go check out something that Cyclone says that we haven't looked at. And I will go back and check our sky once more. And let's just go in there. Check it out. Let me see here. I'm hoping that our sky is cleared for the night. These might be moving in. Let's be careful about that. Oh, look at what happened there. All right. Well, we'll just keep plugging away. Okay. We are using Starlink out there. And one of the problems with Starlink is sometimes we don't have a connection. And that's what's happening right now. But obviously, it does come back, as you can see. All right, so where'd that go? That's better. Okay. there is something that we can look at that I think would be really cool. We'll come down here for now. Again, we're waiting. We have to wait to be able to see it. Measure 100, but we're going to get to it. Okay. Let's see if we can see this cluster. Hey, Curtis. Curtis Horn is with us. Yes, we are, Curtis. It's just that it's not above. He's asking for doing the time lapse. It's just not above the wall yet. We're waiting for it. As you can see, we got clouds passing over. And we want to look at this guy right here. So let's move a little bit west on that one.
Izabela said last night she wanted an observatory where we could roll the walls down.
Actually, the design that I'm using for the next two buildings will be able to do that kind of thing. Actually, it's actually going to be an enclosure that will actually open like a clamshell and go right down, so the telescope will literally be fully exposed. Problem with that is that wind can really cause disruptions. So Terry's having a conversation in Spanish with our wonderful friend from Puerto Rico, Morales, Ms. Morales. Yeah, Izabela says, told you Marc was going to design this. Yeah, I did design it. And you basically have them open so that whatever's in the directions that the doors are opening, there's nothing in either, there's an obstruction in those directions if you have it. Okay, let's, for those just joining us, this isn't really a good exposure to what we do, because we have clouds. This is Messier 46 in the constellation Puppis. The poop deck.
Also known as the stern of the ship.
Well, there's that.
Sometimes we just like saying poop.
What am I going to do with you, Daryl?
I think the whole stream is out of control tonight.
No, it's not.
Chat's been crazy.
A little bit, but they're fine. Do I have to put you in a timeout?
I've already been putting a timeout once today.
You were?
Yeah.
What happened?
Somebody complained about me at Reddit. They wrote me up for harassment. I wasn't harassing anybody. Some snowflake got their feelings hurt. I don't even know who, but they did, and I got spanked for it.
Yeah. See, that's why I just do science, because you can't really argue about science.
M46?
Yeah, and this is a beautiful young hot cluster, guys. Beautiful young stars. And yet, in this cluster, and I'm seeing it through clouds, so yes, that's why it looks the way it does. But in spite of that, we're seeing this object in here, this green, ghostly looking object. What is that? That's actually a planetary nebula, meaning a star's end of life, and that little dot in the middle is a white dwarf. So these are young hot stars that basically just formed in the last few tens of millions of years, And then this one here, it's a star that's already dead. How could you have a dead star in a cluster where all the stars are just a few million years old and can go several hundreds of millions of years in age? Why would one star die? The answer is, it didn't. It didn't. Well, let's say this. It's not in the cluster. This is 2,000 light years away, and the cluster's another 2,000 further away. So that planetary nebula is here. The cluster's way out here, and it's a line of sight thing. It just is superimposed in front of the cluster. Let me see if I can get another shot of it here. Okay. That's all right. Yeah, there's some clouds there, which is inducing all this noise. That better. So that's what this is actually. Again, it's Messier 46. I'll slide that out there for you to see. Okay. It's an open cluster with a planetary nebula, this green thing. The green, if you remember what we talked about, the green is oxygen that's been ionized. And the white dwarf in the middle is extremely hot, 40,000 Kelvin or more. And it can ionize oxygen and hydrogen out to a distance of several light years, you know. And at some point, we'll probably talk about stellar evolution again. The evolution of stars. And you'll learn all about that. I do a talk on stellar evolution, and I go into some pretty intricate detail about how we believe stars evolve. But if you look in here, I know I'm way in, but notice there's like spikes in here. There's detail in here that we could see. Yeah, okay. And the clouds, of course, impart some noise.
We've seen more detail in the planetary in the past, I know.
Oh, yeah. Yes, we have. But we can actually fight some of the noise by doing stuff like this. Yeah. Now our guide scope is also fighting to see through the clouds in order to actually capture these objects. So luckily, it hasn't lost the ability to guide. See, now we can see the red tinges around the outside of this. See, now we're getting some detail in here, Daryl.
Little.
Robert Truckia, how are you? Good to see you. Very nice to see you. Okay. Well, let's save this. And save it just like we see it.
Elisha asks, do you ever have to perform maintenance in person on the telescope? Question mark.
Oh, unfortunately, the answer is absolutely. And thanks to Marianne Robb, who was here earlier, and Terra Diulis, who comes in from time to time, we have had to go out there a few times to fix problems, especially in the beginning. Now we do maintenance visits. Tara and Marianne went out there a month or so ago and cleaned the entire camera sensor, and it was just wonderful. And it gave us views that were just startlingly better. And so that was cool. Okay, let me take us. When we're here already, let me just go into our night vision mode. Okay. So yes, we have to do that. There was one time where, see, this telescope requires power, and the power is underground conduits that we made. However, out in the desert, there's a lot of animals that are a lot bigger than where you might live, and there's rats that are massive out there, and they bite through conduit and they chew up wires, especially the wires that are coated with a soy-based insulation. So we had to buy special cabling that didn't have that on it, so it wouldn't be tempting to mice and rats. But luckily, we're in a good position right now. All right, let's go see if we can see M100 yet. Let's check its altitude. Okay, we're at 40. I think we're good. I think we might be able to do this. Let's go see. Oh, so anxious. Okay. Let's go see if we've got clouds in the east. Probably gonna. Let's go see. We're looking over here now. Well, we might see it. We'll definitely see Ceres. I see clouds moving already. Let's do 20 seconds. It's going to be probably not that good, but we're going to check it out. Okay, do our live stack. Get rid of that. Get rid of that. That's saved. That'll be up there. You might see a little red in it, but maybe not. Okay, so. Well, there it is, right there. Okay, that's measure 100. How do we know? Because I'll show you. All right. And there's Ceres right there. And unfortunately with the clouds, it's making it hard to see it. But we can cut through those. That's pretty interesting. Okay. Let's darken up the backdrop here. Daryl, one of the things, by the way, that we've talked about is getting you a new microphone. So you can, yeah.
We have?
You and I haven't, no, but we've been talking about it. I
Who
think
was we?
me and Marianne.
Oh.
Look at that. Okay, that right there, I'm going to just... Ceres and M100. You can see these galaxies. This is the face-on spiral galaxy known as Messier 100. It's also known as a grand design galaxy. If you look, you can see it's a truly face-on. Spiral arms are stunning, even through clouds. And we're actually, this is Ceres right here. Okay, so if we check it out, I think that this right here is Ceres. So you can see it. Yeah, very nice. So let's take a picture of that. Okay. Save exactly as seen. And now begins the sequences that we take. Now we'll go back to our night vision mode and look at it dynamically. Okay. And we're gonna move it up a little bit. We're gonna move up to it. Okay. Okay. There's Ceres right there. Okay. Hey, I don't care. I'm fighting clouds, but I don't care because this is something. It's sort of a once in a long time event. So,
Yeah, pity about the clouds. I suspect Izabela was hoping, to add to tonight's view
well,
to the last couple of nights. She made the GIF out of
yeah,
GIF, whatever you want to call it.
but we can still do that. Because the clouds come and go.
Yeah.
So what's really going on here, guys, is this. Okay, Ceres is photobombing this galaxy. And let's do a 25-second shot. And again, this will provide another data point for us. There we go. And we can... For those of you that missed it a couple nights ago, what you missed was a amazing capture that we did of Asteroid 2023 DZ2 as it came into the Earth-Moon system. It actually crossed, closer to the Earth than the Moon. It was in between our orbits. And it was just beautiful. And we actually saw it moving in real time right across the sky, like about this speed. And then my cursor. And we watched it go through. Okay. We'll save that now.
Some reports on that were mistaken. They said the comet flew between the Earth and the Moon. And actually, it came closer than the Moon, but the Moon was over on the other side of its orbit.
Yeah.
So it never passed between the Earth and the Moon, strictly speaking.
It was closer to us than the Moon's orbit. It was within the Moon's orbit.
Right. Well, you can kind of see the galaxy now.
Yeah.
Could you show Izabela's results from last night again?
Sure. Okay, so while this is doing more imagery, this is Ceres right here. All right, there's where it started. That's where it ended up, and watch, tink, it moves a little bit more. You see the times? Okay, at 10:30 it was there. Okay, I'm guessing this is her times. March 5th, 22:30, March 8th. Oh, she changed the way the date. Okay. All right, 25 March, 8:22. Okay, 4:55:09.
And then tonight you can put your pointer about what, yeah, it's right about there right now.
Yeah. Very cool. There you go. That's Izabela. Did it for us. She's a superstar. She's Superfly. Okay. All right. And we'll take another image. When the comet came through, we were actually doing this too, because the comet was moving considerably faster in our relative sky. So we took a lot of pictures. Thank you, Curtis. Curtis says, nice time lapse, Izabela. See that? And Curtis is a knowledgeable guy, I can tell you that. We just talked the other day on the phone. He had called. I called him back. So, neat. I think we're in the clear here, so I'm going to clear this. And take a look at this again. There it is again. That's nice. Okay, let's move in a little bit on it. There we go. Okay, that's too much. Okay.
Hopefully, maybe that will give Izabela enough to work with. I mean, you know, if she can use the earlier images of M100 and plop Ceres over into the new position over it.
Well, I don't see why she wouldn't be able to. Good night, Cyclone. You can start to see those beautiful grand design spiral arms now. That galaxy is facing us like this, not like this or whatever. It's right on. Really pretty. Okay. Very nice. All right, let's color correct one time here. There we go. Now let's save it. What do I want to do now? I'll try something else. Take out the label there. And let's come in here. Just a minute. Zoom in even more. And let's try to see when it crosses the line or starts to cross the line. So again, that right there is Ceres. And let's see, let's watch what happens.
Well, the galaxy is coming out a little.
Yeah. Well, I'm stacking, so we got 8 stacked here.
Yeah.
And we should see that Ceres will start to show up on the other side of this line. So we just gotta let that percolate. Oh, Alicia is leaving us tonight. Okay, good night. I hope you and Darlene have a wonderful evening. Thank you for coming.
This may take a while.
Yeah, I mean, I just want to... I put it right at the edge so we can just see it peek through.
Yeah.
I mean, obviously, the Ceres is not that diameter, obviously.
No.
It's a pinpoint, but it's bright enough so that it saturates the sensor and makes it look bigger. Okay, look, we're getting a little bit on the other side now. That's all I wanted. I wanted to see that. You see it?
Maybe.
Yeah, there's a little tiny white protrusion poking through now.
Well, it is 1.6 or 1.8 astronomical units away, so...
Well, the whole... To go from here to here is going to be 6 hours.
Yeah.
So we have to consider that. So I'm going to get rid of these guys for now. Zoom in some more. Okay. And we'll save it. Save it again as seen. And then I'll clear it and do another photo. Oh, Michael, you asked about this earlier. I'm sorry, I forgot to discuss it. Michael asked a question. Michael Hedrick. Could Mark talk about the Oort cloud and asteroid belt now, please? Yes, as a matter of fact. Oh, I think we got a cloud here now. I think we got clouds. Let's see. Just a second, Michael. Or maybe not. Okay, the asteroid belt and the Oort cloud. Okay, the Oort cloud, okay, our solar system is laid out with the planets, but between Mars and Jupiter, we have an asteroid belt. Now, that's an asteroid belt and not a planetoid, a little tiny planetoid, because Jupiter has been massaging the asteroid belt. As the asteroids are closer to the sun, they move faster around the sun than Jupiter does. So every time they pass Jupiter, they get tugged out in their orbit a little bit, and they go back in. Back into their orbit, out and then in as Jupiter tugs on them. That tugging process has been more than enough to prevent the asteroids from coalescing over the billions of years into a planetoid. And you might ask, well, if you take all the mass of all the asteroids out there and put them all together to make a planet, how big would that planet be? The answer will surprise you. It would make something that's only about a fourth of the size of our moon.
Yep.
So it would only be a small object. And you say, well, wait a minute, there's hundreds of thousands, if not millions of asteroids. Yes, there are. But a lot of really tiny ones out there. Some the size of your fist, but they're in the asteroid belt, so they're considered part of the asteroid field. But so that's the asteroid belt. And that stretches from just past Mars to just before Jupiter.
Can I add something before you move on?
Sure.
We've talked about this before. A lot of people have the wrong idea about the asteroid belt for watching movies. If you went out in the asteroid belt, it would not be like a Star Trek or Star Wars episode where rocks are bouncing around you constantly. If you were out in the asteroid belt and you looked around, you would not see any asteroids. You wouldn't notice anything. They are so far apart, so spread out that probably wouldn't see anything at all.
Yeah.
Not like tumbling fields full of boulders,
right?
Like in the movies. They do that for dramatic reasons, for it to look interesting.
Yeah, that's true. If they did it the realistic way, it'd be like, boring movie.
Yeah. Yep.
But one thing to keep in mind, which is actually pretty important, is that Saturn's rings look like they're pretty dense, don't they? But the Cassini orbiter was purposely driven through the rings to get data on the rings. And they didn't have any fear that it would strike anything, because just like that, just like what Daryl's telling you about the asteroid belt, Saturn's rings, those particles are very far apart from each other. It's not like they're 200 feet apart from each other. They're many miles apart from each other, hundreds if not thousands of miles apart from each other. But because the rings are so far away, the conglomerate, the sum total of all those particles looks like it's solid, to make Galileo's ears on the planet. Okay, but in fact, it's just a very tenuous ring. They're just highly reflective.
If you look on YouTube, there are several variations of the video, but if you do a search on YouTube for asteroid discovery 1980 to 2010, etc., and 2016, I think there's different end dates to them. Mm-hmm. There are a number of vids there that show look down from the northern pole plan of the solar system of the planets orbiting and the numbers of asteroids that were known at the time and their rate of discovery. And it's really informative to watch these videos over the course of time to see how the true or the more realistic numbers of asteroids have increased over time as we have detected them. And interestingly, the rate of discovery went up a lot after comet Shoemaker-Levy 9 hit Jupiter back in 1994. But it's fascinating to watch these videos, and you can get a lot from that.
That's
and
right.
There really are a lot of them out there, and some of the when you see the planets orbiting the sun, you'll see Earth is the third one out, and Mars is the fourth one out, and you'll see that they're not only in the asteroid belt, they're all over the solar system, and there are a lot of Earth-crossing asteroids.
Yep.
And some of them are colored red in these videos, and those are ones that I guess are Earth crossers, or possible, they're capable of hitting the Earth.
That's right. And then there's a program called the Sentry program, which actually studies and looks for these asteroids and catalogs them. Every new discovery is put on the Sentry list. Every new discovery. And then as they get the orbital elements, that is the characteristics that make it the orbit, we can then calculate whether it's ever going to hit us. And if it's not, well then it comes off the Sentry list. And if we have incomplete data, then we don't take it off the Sentry list out of an abundance of caution. Okay, now, so that's the asteroid belt. And as we said, there's a lot of NEOs, near-Earth objects. And Jupiter, for instance, also has asteroids ahead of it in its orbit and behind it in its orbit.
Trojans.
That's right, the Trojan asteroids. And Earth actually has a Trojan asteroid as well that's known, a couple of them. But those are in stable positions in the orbit. They're at the Lagrange points. They're called parking spots in space. And they move and they orbit the sun, but in the same position. So they're stable. Now, beyond the asteroid belt and beyond Jupiter, beyond Uranus, beyond Neptune, and beyond Pluto, which is a planet, by the way, in my view, we have the Kuiper belt. Kuiper. The Kuiper belt is the realm of icy bodies. And it's sort of a belt, another asteroid belt-ish thing. And it's a disk of icy, highly populous bodies out there. Again, there's a lot of them, but the Kuiper belt is massive because it goes around the whole solar system. So if there were 1 million objects out there, and at the width of it and the distance away, it still means you're going to have very few visible to you, if any, when you're out in the Kuiper belt. So beyond the Kuiper belt is yet another belt labeled the Oort belt, O-O-R-T, which goes to, I think it was Michael that asked the question. Maybe. Anyway.
Yes.
The Oort belt, like the Kuiper belt, is again another realm of icy bodies. In addition to the Oort belt, we go even further out, and we have a sphere of particles and objects around the whole solar system, known as the Oort cloud. Now, what's interesting about the Oort cloud is the Oort cloud goes literally at least halfway to the nearest star, Alpha Centauri. And that's a finding that was stunning, not obvious initially, but it's true. So our Oort cloud is a couple light years in size, which is pretty interesting. So on that you can look up and see all that for yourselves if you wish. So I've been I've been clearing this image and letting it go for a while and taking new images so that Izabela has plenty for a time lapse. So it'll be pretty cool. Okay, so that's the next one. I'll let a few come in before I...
Gee, I didn't realize that Scott Manley had done a lot of these asteroid discovery videos. Some are by others. He has done a lot of them, though.
Mm-hmm.
Yeah, these are really interesting videos, folks. The 1980 to 22 is a classic, but they've kept updating them ever since. You can see the planets orbiting counterclockwise around the sun, and Jupiter will be the outermost one. It moves out near the edge of the screen, but you can also see the Trojan asteroids moving 60 degrees ahead of Jupiter and 60 degrees behind it. Shows them all, and you watch over the course of time, and you will see how you get a better idea of how many asteroids there really are, or you know, that we're still discovering to this very day.
Yeah. Well, that's beautiful. Go ahead and take a picture of this. When you go into this directory, guys, if you do go into this directory, you're going to see lots and lots and lots of subdirectories, and those will all be the separate times that I snapped this photo. And it's going to be in the Ceres and M100 directory out there. Izabela put up a link to it already. So our solar system has lots of junk in it. Lots of stuff, lots of additional icy bodies. And there's a point in our solar system where the sun's influence is exactly negated or counteracted by pressures from interstellar bodies and other stars out there that are spewing their radiation, and where that our solar influence stops because it's being stopped by being hit by other radiation from other stars, that's called the heliopause. And that is where our place in the universe ends and the unknown begins. And the Voyager spacecraft, both of them, have crossed the heliopause and are now out in true interstellar space. So when you look at the motion, look for these two little objects here. These two little stars, or objects in this galaxy. I think they might be stars, I'm not sure. I think we agreed that there might be stars. And watch how Ceres passes it. And compare it to the first one we took, and you'll see that it's in a different spot. I did take a cough drop incidentally, just so you know. So if you hear clacking, that's the cough drop.
Okay.
Alright, while we're waiting for this, let's go see what our sky looks like. Looks kind of clear. Let's go see if it is. The sky changes so fast out there. Yeah, it's relatively clear.
Better.
Yeah.
A little.
Okay. It's better to have more data up there than less data. Izabela, that's correct. There's a little one right there. We zoom in on that, I can show you. See, we have a star here. We have one here. We have one here. And then we discover that they're moons of Ceres. No, just kidding. There's no moons of Ceres. Could be. Pluto has 6 moons, 5 moons. And Pluto's a planet. Okay. Yeah, pull this down a little bit. So we get some spiral arms there that look a little better. Okay. Now let's clear it and see if the next image of Ceres looks any different. It will be, but it's just minuscule. The first one is not that good because we're actually building the image. Oh, looks like there might be some clouds here. Maybe. We'll find out. That's noise, and that gets eliminated as we stack another object. Once you watch the second one get stacked right here, you'll see this noise get dropped down. Watch. Boom. Look at that. And that will continue as we stack more. Because it's that noise that we're averaging out. The data gets brought to the top. As the data gets brought to the top, it looks better. There we go. See, by the third stack, you can start to see the spiral arms very well. So you guys having fun tonight in spite of our little bit of cloudy skies? I hope you are. Alright, let's save this again. See, what I'd like to see is if somebody does a gravitational lens study to see if the gravity of Ceres can successfully bend starlight from that distant galaxy. Because this is a perfect gravitational lens candidate. Now, Ceres has very weak gravity. In fact, you only have to move about 1,000 miles an hour to escape Ceres. That's its escape velocity. So that's not a whole lot compared to the escape velocity you need to get away from the Earth. But it's still interesting. Thank you, Bonnie. I don't think I said hi to you tonight, Bonnie. I'm sorry I missed you.
Bonnie was fashionably late tonight.
Oh. Hello, Bullwinkle. I don't think I said hi to you either. Bullwinkle says, let's hear it for the planet Pluto. Yep. I got you covered. I'm with you on that. Okay. Now we'll clear this. Let's check out whether maybe while we're waiting, do a couple of extra minutes here. Let's find out if maybe we can observe something else. There's Ceres. Yeah.
Ray asked if you have any plans to attend the NEAF in Boston. I think it's Boston.
When is it?
April 2023. The Northeast Astronomy Forum.
Yeah, I haven't been, marketing STLS to any of these places, and I should probably do that because right now we're just a YouTube phenomenon, So, but I do. I won't be going this year. No. I'd like to.
Yeah. Oh, it's a big show. It's
yeah.
All the manufacturers show up and show off their wares.
Oh, you mean Celestron? And of course you have Oceanside, OPT, Orion.
Yeah, a lot more than just them.
Mm-hmm. Yeah, well, the High Point Scientific will be there, I'm sure.
Well, not just vendors, manufacturers.
Mm-hmm. Trouble is, Meade and Celestron, they're owned by the same parent company in China. And there was a price fixing lawsuit against them. It's possible that I paid $1,000 more than I should have for this telescope because of that. We received that in writing, that that's probably true. No fun. That's all right. All right, let's try something.
I've been reading about that. I know Meade was. Celestron was in on that too.
Mm-hmm. Yeah, Celestron and Meade are owned by the same parent company. All right, we're going to go to this object here, and then we'll be back. Let's see if we're going to be able to see it. There it is. This is Messier 53, a globular cluster, known as a halo object. It's in the galactic halo. So this is just something to keep us from taking tons of useless pictures of Ceres crossing M100, and then we'll come back and take some others. Hey, Eric Briggs, thank you. Says Orion will be repping Meade. Yeah, that's pretty cool. I'm I've always had Meade telescopes, but I'm not against Celestron whatsoever. In fact, I toured the factory out there in Torrance, which is probably not there anymore.
Well, he says OPT closed their storefront.
Yeah.
I remember I liked Pocono Mountain Optics back in the day.
Oh, yeah.
They were in Pennsylvania. They were a great bunch of guys to deal with, and I really enjoyed them. They shut down a long time ago. Turned out the owner was a gambler, and he gambled all the money away, so they had to close the store.
Wow. So this is the globular cluster I was telling you about. I went to take do a 25-second shot of this, and then we'll go into the stack and clear the previous stack. All right, it's gone already, and I'll get rid of this, and then in just a few seconds we'll see a globular cluster. And there it is. This is Messier 53. These globular clusters are fascinating objects in our universe. And the interesting thing about these is that these are composed of some of the oldest stars in the universe. They're so old, in fact, that when they were made from some of the purest materials in the original universe, which was hydrogen and helium, and a smattering of other light elements. Consequently, there's no heavier elements in these stars in their spectra. They're pretty much a pure spectrum from the hydrogen perspective, and they're called population 2 stars, which is different from, you'd think they'd be population 1 being the original ones, but they're not. They're called population 2, and these stars in here are deficient in elements like calcium, magnesium, phosphorus, potassium. So they're pretty pure. And what's that mean? It means that most likely we wouldn't find a lot of planets around the stars in these clusters. And these clusters can have several 100,000 stars in them. Okay, so a cluster like this might have, say, 60,000 stars. Or so, I'm guessing on that, but that's approximately correct. So, but this would also mean that we would end up having a cluster that, being a halo object, it moves around our galaxy. It's orbiting the galaxy, and many of them do. This is not just one. We have many globular clusters around our galaxy, and there's many around other galaxies. So it's pretty interesting how these things actually work, because as they rip through the galactic disk, they might shed a few stars, and they might actually pick up a few stars as they go through, for the ones that actually pass through the galactic disk. But just like what Daryl was talking about with the asteroid belt, and what I was talking about with Saturn's rings, it's possible that they wouldn't ever encounter another star as they go through. You know, if they go through a particularly dense area, there might be a chance that they could pull one along for a bit and maybe capture it. And this could lead to some interesting combinations of material, of stellar objects in these clusters. So let's zoom in on this for a bit now that we're here. Here we go. And what we do is we're going to reduce the brightness so you can see that it's a cluster all the way to the core. I remember Jim's mobile.
Well, his first. He was a TV repairman, and his first astronomical product was RoboFocus.
That's right.
And he went from there. And he, where was he? He was north of Colorado Springs, Golden, somewhere up there around Denver. I forget. And he used to come down for astronomy club meetings here in town occasionally, and he'd bring some of his toys. He brought a 25-inch portable Dobsonian once.
Wow.
Well, no, it wasn't a Dobsonian. It was, I forget what it was. It was a compound telescope, strip telescope. And he had built up, I want to say maybe a 40-inch. And the one he showed us at one time was a 25.5-inch telescope. If I remember correctly, it was bright yellow.
Yeah.
He built it for somebody over in the Islamic world, so they could use it for spotting new moons to help determine the lunar months, lunar cycles over there.
Okay.
And whoever it was paying for it, they bought a very fancy telescope.
Wow. Whatever happened to Jim?
I don't know. He, as Eric said earlier, he sold out years ago. Sold to Farpoint Astro or somebody. He might be dead for all I know now.
Okay.
I don't know.
Okay, so...
He came with a very groundbreaking product, though.
Yeah.
He sold an 18-inch telescope on a horseshoe mount, equatorial mount, for several years. It was quite an amateur telescope.
Wow. Okay. All right, so we did this. We did M53, and we discussed what halo objects are. Now, we'll go back to Ceres, and we will check out how it looks and see if we can see any differences in where it is. So there we go. On our way. Zing! Alright, let's do this.
Yeah, you remember the good old days when people used to fix televisions?
I do.
That's how Jim got his start. He was TV repairman.
Reminds me of the Monty Python skit where everybody is Superman and has capes. Everybody, you know, and mild-mannered Superman by day, but at night he's bicycle repairman. Funny.
And for some time, I know, back to the days of the TV satellite dishes, he was building satellite dish mounts to help pay the bills.
Do you remember the size of satellite dishes? They used to be 8 feet in diameter.
Oh, yeah.
Yeah. Crazy. All right. Let's go in here. Now we're back to Ceres. And let's do that. Ceres and M100.
Jim's Mobile did a series of amateur binocular telescopes also.
Oh, yeah. Okay. We still got clouds, but we're going to do it anyway because we want to get this next data point. And we're going to clear this. So here is, we have some clouds, obviously. That's why we're seeing it like that. Got to get those to go away.
Izabela has a question. Can Marc talk a little about those Z equals 14.3 galaxies found with the Webb telescope, how they formed so early, and what are the stars in them?
Okay, first of all, I have to define Z because people don't know what that is. It's a redshift, it's called. It's a parameter that you get from a calculation that gives you the distance to the galaxies, basically. And the farther away galaxies are from us, the faster they're moving away from us. And galaxies that are moving away from us, let me first of all focus on this one little thing right here.
This pertains to what you were saying earlier about globular clusters and, you know, the population 2 stars.
Yes. So clearly Ceres has moved a little bit. So I'm going to save that just like that.
Oh, it has.
Oh, I already saved it. Or is it still in the same exposure? That's why. Just a minute, Izabela. Okay, it says the disk is full, but it's not. That's what the message that it gives me when I go to do this. Okay, just a minute. We'll clear this. I'm just going to confirm.
Izabela, I could hazard a little bit about that.
Wow.
I'll let Marc take over.
Yeah.
You were asking about globular clusters and the galaxies so far away that Webb discovered way back then. Very young universe, you know.
Yes.
Well, everything back then was made out of the same stuff. It was hydrogen, a little bit of helium, and a tiny little bit of other things like lithium, I guess. And,
yeah.
you know, nothing back then had much metallicity to it, as they call anything heavier than helium. Cosmologists, that is. And so everything that was created early in the universe was made out of the same metal porous stuff. And the metallicity increased over time through successive generations of star birth and death.
That's right. Let me go out here. I'm going to come out to my... Yeah, see, disk is full. It is full. And I gotta just go fix that. And there's a number of ways to do that. This is the... Okay, these are all uploaded, and those should be okay. I'm going to just take out a directory. It's preserved on our server. see what we did. $172 meg. That's good. We need more. It's alright, because the time it takes for us to do this, it's not going to be a big deal. Okay, and then this. Okay. Okay, we should be good. I'll be coming through and cleaning this all up. Alright. Got that. And we got this. And let's do this. And color correction. Alright. And after this, I'm going to do a focus again. Okay. 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 Now we did that. We're going to focus. Put it on there. Okay. And we're going to pull the focus out. Okay, one more level. Then go in. This will give us our nice, sharp, clear, perfect focus. Okay. So, back to the question. James Webb Telescope, the problem we've had traditionally was that when I mentioned how galaxies that are farther away from us, they move faster away from us, their data, their light data is also shifted into the red end of the spectrum. And that shift into the red end of the spectrum is the problem, because if you go far enough into the red end of the spectrum, you can go right out of the spectrum that you can see with your eyes and end up out in the infrared. And so Hubble noticed and saw galaxies that were showing data in the infrared. Because they're speeding away so fast, their light is redshifted enough. And it has to do with this redshift parameter we talked about. Izabela brought up the 14.53 or whatever. And that redshift data is something that is leaving those galaxies out of touch, out of reach by all of our instruments until now. Now, with the James Webb in play, it sees so far out into the infrared, that we can actually see galaxies that have just in the early stages of formation. But there's a wrinkle here, because it also looks like there may be problems with how old we have gauged the universe to be. In fact, the universe might be twice as old as we think. And this itself would solve a conundrum, puzzle, of why we see, as Izabela pointed out, fully formed galaxies so early in their development, apparently. And it has to do with the fact that these galaxies might have been around for twice as long. And that data is still out. That's a new field of study right now. But boy, oh boy, that would really cinch it up for a lot of people, because they think the universe is older. we already know it's over 92 billion light years in diameter. And there's people out there saying, but wait, it's only 13.8 billion years old. Well, yes. And you say, well, how can it be 92 billion light years in diameter? Because what you got to remember is that we've seen the light coming at us for 13.8 billion years. And then when it gets here, we see that light 13.8 billion years old. But in the time it took for that light to get here, the universe has continued to expand. And so the light for the universe has expanded again another 13.8 billion years beyond where it was when that light first started coming to us. So that leaves us with quite something to puzzle out. By the way, look at the difference now of Ceres versus this. So we're going to save that. That's a good data point.
And the red star, 10 o'clock Ceres, come out. Looks like it's coming out from behind it.
Yep.
Or from its glare, anyway.
Oh, I got to resume my stack here. Hold on. All right, let me just wait for this next frame.
It's looking much nicer now.
Yeah. Okay, let me click this over here. And let's look over here. Okay. Save exactly as seen.
Is the cosmic microwave background, is it farther away than they thought? I was under the impression that was like as far as we could see at the 14.3 billion years or whatever.
13.4 actually.
13.4 or whatever, you know what I mean.
Yeah, I do. Well, here's the thing. The whole universe is expanding, and as we've discovered, it's actually accelerating as it's expanding. So the universe is a lot bigger already than we thought it was. And it might also be almost twice as old. And the cosmic microwave background was at that spot we see it in now. But over the last 13.8 billion years, as that light's been getting to us, it's been expanding further. So it's farther out too. Everything is farther out. And to go through this it's a real brain teaser to try and figure this stuff out.
Makes my head hurt.
Well, I think mine hurts just because I've been staring at the screen for so long.
Maybe that's it.
Yeah.
I'm going to have to call it a night here directly.
All right. Okay, so we are looking at this. Dwarf planet photobomb of a galaxy. Pretty cool. Let's go see one more time where our clouds are at this point. Now, because we have to go soon, I bet it's, yeah, see, now, of course it's getting clear. Because we have to go. That's all right. Not a problem. Now this has been pretty cool. We'll clear this and do one more. Izabela, I think I've given you quite a few images to pick from. Hello, Maziv. How are you? You're showing up just as we're about to, head in for the night. And he says, Maziv says, I captured Ceres tonight on the 10-inch. Pretty neat. Yeah, I know, huh? Here, this is our first image, and then the second one will look nice. And the third one looks even better. I've been streaming for 3 nights in a row, Curtis, so I probably have to give it a bit of a break. I'm supposed to do 2 radio interviews, and then I have to do a station here in Connecticut wants me to come on at some point to talk about the Pentagon announcement that there might be a mothership in the outer solar system that's seeding probes into the inner solar system. Well, as far as I'm concerned, that whole thing could very well be true or may not be. But the author of that paper, Avi Loeb and Sean Kirkpatrick, I know Avi quite well, and we've worked on television productions together. And he's interesting, and what he's talking about could very well be true. But he also is the one who but wrote the book on Oumuamua called Extraterrestrial. And his commentary is very, very good about this and very prescient, as we say, all right, and takes into account the latest science. And what he's suggesting is that UFO visitation here could be the result of a mothership that's actually sending probes to our planet. And why would he say that? Because that's what we would do if we could. That's what we would do. And I don't disagree with him at all. I think he's probably right on the money, actually. Okay, that's a good one. Save, and save exactly as seen. All right. All right, folks. Well, this is the last image for tonight because Daryl's got to go to bed.
That's all my fault.
Right. Sure. Okay, so let's take that out. I hope you guys had a good time. And we make the best of a cloudy night, don't we? It's actually not bad though. Didn't come out badly. All right, so let's do that. All right, and honestly, not a bad bit. So I'll show you. Actually, I'll show you the closing procedure right now because why not? All right, so first of all, I get rid of our planetarium. Okay. And then I take the telescope and I do what's called park it. Okay, and if you watch the telescope, you'll see that it's going to move to a predetermined position, which is where it's going now. Okay. And then once it gets to that predetermined position, it stops. And okay, you'll see the remaining stars there, and then you'll start to see them drift. What are you seeing? You're actually watching the Earth rotating out from under the stars. Because normally the telescope is following the stars. But if it sits like this, it's rotating out from under the stars. Okay? So it's facing the same point in the sky. I'm sorry, it's facing into the sky, and it's looking at the same point right, while the stars are rotating out from under us. So if there were geosynchronous satellites out here, and we took a time exposure, those would show up as dots, and the stars would look like dashes. But when we're following the stars, geosynchronous satellites, the ones that go around the Earth once per revolution, would show up as dashes. Okay, I know it's busting your brain at 1:30 in the morning, East Coast, but that's how it works. Okay, so now we can shut the power down. This over here, I have a microcontroller that I wrote software for. Okay, and now we shut the roof. There we go. 2,600 miles away. Gone. And the scope is now gone to bed for the night. Alright, folks. Well, there we go. Thank you so much for coming. And I am quite happy that you came to see us tonight. I am very happy that Daryl has joined us again tonight, even though he's yawning in the background because this was a long night, you know.
Could you hear that?
Oh yeah.
Okay, sorry.
I don't. I'm not a problem with it. Not a problem at all.
Good night, everybody.
So you guys have a good night.
Thank you for coming.
Yeah. All right, guys. We will see you the next time I can stay awake. I'm actually awake now, but we'll see you guys later. Have a good night, and let us know what you think. Go to SkyTourLive.org to check out all of the imagery, and also to contact us and leave us messages. Let us know what you think. All right. Also, check out our Patreon. All right. Our Patreon subscribers are wonderful people. Right here they are. So far, we have John P, Izabela M, Ali B, Chief McCyber, Vera Campos, Ronald T, Martin, Raymond B, and Cindy M. I want to thank you guys for being our patrons, and we're looking forward to many more patrons to join us and help support what we do. Until then, have a good night, guys, and we'll see you later. Remember to keep looking up.